Hi everybody, welcome back. We're continuing Chapter 3 on vectors, and in our last video segment we had used trig functions to determine the dimensions of, well, for lack of a better word, a right triangle. And these right triangles out of, this is the example that we did in the last one, they're made out of vectors at some sort of angles right here. This guy has a distance or displacement vector, right, from him to the top of this cliff, and it's at some angle. We were able to determine that because of our knowledge of the relationship between the x and the y components that right triangle creates. What I'm going to do is talk about today how to take the components and resolve them back into the vector itself, and also how to find that angle. So let's say we have this right triangle right here, and this is some vector A that is some unknown magnitude, and it's at some unknown angle theta right here. What we want to do is we want to find out what that magnitude and that direction is, simply based on our knowledge of what the x and y components are. In fact, I'm going to erase that. Usually I do x in green and y in blue, so I'm just going to try to establish that right now. So here's our x, and then our y is blue. And let's just say, and this will be pretty easy, that our y component is 3 meters, okay, and you probably guess where this is going. Our x component is going to be 4 meters in the positive x direction. How do we find out the hypotenuse? Well, you probably know from math that the hypotenuse is going to be 5, but how do we find that? Well, we know that because of the Pythagorean theorem. Now, the Pythagorean theorem would state that the hypotenuse, that is, our hypotenuse being the vector itself, the hypotenuse squared is going to be the one leg squared, so ax squared plus ay squared. If we want to solve just for that vector A, well, how do we undo, oh, you know, I had to put the square. Here's a square right there. How do we undo that square? We square root it, and so we square root this side, it becomes regular vector A, and so this becomes a square root of ax and ay. So ax is going to be 4 meters, so 4 squared plus 3 squared is going to be our y value, 3 squared. We all know that's going to be 25, and the square root of 25 is going to be 5, and so that's going to be our vector magnitude right there, 5 meters. Oops, I shouldn't put the arrow over the 5, it should be over the a. So that's how we find the magnitude, or the amount of the hypotenuse. We simply use the Pythagorean theorem. So we square the x value, square the y value, add them together, and then take the square root. Okay, but what if we want to find the angle of this vector right here? Well, first of all, this right here should say theta. It should not say alpha, so that should be a theta right there. All right. Well, we know from the very outset the x component, circled here in green, and the y component, circled here in blue, and they form right angles. So they basically form the leg, or the two legs, of a right triangle. And so the question is, what trig function deals with the two legs, or you might say the opposite and the adjacent? Because after all, the x component is going to be the adjacent, and the y component is going to be the opposite, if we have that angle in there. All right, what trig function is it? Well, that's tangent. And we know that the tangent of an angle equals the opposite over the adjacent, which really winds up being, so the opposite of this angle. So here's the angle, and this opposite, so that'll be the y value, right? So a y over the adjacent would be a x. And if we have the y and the x value, we know that the tangent of the angle is that relationship, or that fraction, that ratio right there. Well, what if we want the angle itself? We know the tangent of the angle is this fraction, or that'll be a decimal. How do we get the tangent itself? Well, or the angle itself, how do we undo the tangent? We take the inverse tangent. And it should be right above your tangent button on your calculator. Just hit the function, and that'll give you your tangent to the -1. That says, all right, well, if the tangent of this angle is that fraction, or that decimal, what is the angle itself? So, for our purposes, we'll say the angle is the tangent What was the y value? I believe that was, if we go back a second here, I can't remember if that was 3 or 4. Oh, that was 3. All right, so our y value was 3. And our x value was the 4. Okay, so that was going to be our 3 meters over 4 meters. That's our fraction right there. And so that would give us the angle that the previous triangle that we had created creates. All right, so the inverse tangent of 3 over 4 is 36.9 degrees. I'd probably round up to 40 degrees. All right. So that would be, if we go back to our previous, that's what this angle would be. So you know how to find the hypotenuse, or the full magnitude, and now you know how to find the angle itself. So 40 degrees. Now there's one more thing we need to add to that, however, and that is a statement of what quadrant it is in. All right, and that depends on the y and the x components. Well, we've got a positive y, right, because y is kind of going up in this direction right here, and we've got a positive x is going this direction right here, and so that means we have our angle, which is going to be, we can say it two different ways. We can say that it's going to be north of east, or we could say it's above the positive x-axis. Both of those are legitimate ways of saying it. And so depending on the values are, if your x is less than 1, all right, or if your x is negative and your y is positive, that would be north of west. If both your x and your y are negative, right, negative x, negative y, that's going to be south of west. Positive x, positive y, we said that before, that's north of east. And our positive x and negative y is going to be south of east, like that. These also correspond to the above the positive x, below the positive x, above the negative x, and below the negative x as well. I just didn't write them in there. All right, so that's how we find the actual values for magnitude of a vector and also direction of a vector, and being very specific about what the actual quadrant is that it's in. All right, so let's do an example. I'm going to do example 3.3. All right, and so we are given two values. Now I'm just going to write in red right here, even though I said I'm going to try to write x in green and y in blue, but I'll continue that later. We're given the x value and the y value right here. All right, and let's find out what this vector is going to look like. So the first thing we want to do is let's just sketch it. All right, so starting from the origin, we have a negative 9 meters in the x component, and we've got a 40 meters. This is probably not going to be to scale. A positive 40 meters in the y component. All right, in the y direction right there. I will change the color for the actual vector itself. I'll just make it black. So the vector itself is going to be kind of the sum of those two added together. So that's going to be vector A. So let's find the magnitude of vector A right there. To find the magnitude of vector A, we take the Pythagorean theorem, right? So it's going to be the square root of the x squared plus the y squared. So it's going to be 9 meters squared, this is square right there, plus 40 meters squared. Now why did I not put negative 9 right here? Well, you know what happens if you square negative. It becomes positive anyway. So if you want to just save a teeny tiny bit of time, you can really just put the absolute values in here. It'll give you the magnitude. Remember, the magnitude can't be negative anyway, so it'll always be a positive value. So if you just want to put the absolute values in here, that's completely fine. All right? So 9 squared plus 40 squared, and take that to the 1/2 power. That gives us 41. All right, so A is going to be 41 meters, but we're not done yet because we need the direction, right? So the direction of A is going to be the inverse tangent, tan to the negative 1, of what? The y over the x, right? So that's going to be 40 divided by 9. Once again, I put the absolute values in. You don't worry about the negatives. All we really care about what that angle is right there. So the inverse tangent of 40 divided by 9, I get 77. 77. I'm trying to write an equal sign and then a 7. Sorry, equals 77.3 degrees. Okay, so we have a magnitude right here, we have a direction right here. The last thing we need to really state is the quadrant that it's in. So if we look at our original drawing right here, we've got a negative x and a positive y. What quadrant is that going to be in? It's going to be north of west. Here's west and here's north of it. So our whole statement for our vector is going to be 41 meters at, I should write vector A, 41 meters at 70, I'll just round it to 77 degrees north of west. And that would be your complete statement for your whole vector. All right, that we reassembled from these two components right here, AX and AY. Let's do one more together and then I'll wrap up this video. We're going to try and vector B now. All right, this is actually very much the same as vector A. We got negative 8 meters in the x direction, or 8 meters, I should say, in the negative x direction, and the y component is going to be positive 15 meters, like that. And so the full vector B is going to look just like that right there. So that's vector B. Let's find the magnitude. Let's find the direction of vector B first. All right, we'll change it around a little bit. So the angle for vector B, that's going to be the inverse tangent of what over what? That's going to be the y over the x, right? So 15 over 8. And again, I just put regular old 8 because we can use the absolute value. Inverse tangent of 15 over 8 is going to be 61.9 degrees. Let's call that 62 degrees. All right. Let's look at the direction. Well, we know the angle, but what's the actual quadrant that is in? We've got a negative x and a positive y. Again, that's going to be north of west, like the previous one, right? North of west. So we can write that in just right now. Excuse me. All right, let's find the magnitude now. Magnitude for vector B is going to be what? It's going to be the square root. We're using the Pythagorean Theorem of the x squared plus the y squared. So 8 squared, I'm using the absolute value because the negatives don't matter because we're squaring them anyway. 8 squared plus 15 squared. All right, 8 squared plus 15 squared. I'm doing this on my calculator as we speak. Take it to the 1/2 power, we get 17 meters, and that's going to be our magnitude. So our full statement for vector B is going to be 17 meters at 62 degrees north of west. Box that up. That's going to be our final answer for vector B. All right. Let's ask ourselves, does that make sense? Well, first of all, the 17 should make sense, right, because it's longer than both these legs right here. And this is a fairly high angle, so yeah, 62 degrees. That sounds about right. Okay, so that's vector, so that's example 3. And I'm going to stop there for the time being, and we're going to pick up on the next video with the graphical addition of vectors and then the component addition of vectors. So thanks for following along. I'll see you on the next one.